Hello friends, my name is Amit and on behalf of True Robotics, we welcome you to our course on business statistics. So let's start. So the first lecture which we have is on descriptive statistics. So let's see what all topics which will be covered during this first lecture. So we'll understand what is statistics. We will also understand what do you mean by samples and population. We will also cover census. We'll also understand two main areas of statistics which is very important, descriptive and inferential statistics. We'll cover what is parameter and statistic. We'll also understand variable and data sets, types of variables, quantitative and qualitative, types of measurement scales which can be divided into 4 different categories. We'll understand that. Type of statistical techniques which is used. We'll also cover that in this topic. So let's start with understanding what is statistics. So statistics is an important decision-making tool in business. It is defined as the science of gathering or collecting data, interpreting data, analyzing data, and presenting data. Now we'll understand what is a sample and population. First, let's cover population. Population can be defined as collection of persons, objects, or item of interest. If you see this image, this is a population of cars, which is of interest. So there are multiple cars and researcher is interested in knowing about this set. So this becomes my population. Now let's understand what is a sample. A sample is a portion of the population and if properly taken is representative of the population. So now if I pick up one car which is red, yellow, or maybe let's say randomly a black, so we'll have a new set. This can be classified as sample. Here we have the image also. So we have sample 1 which is a combination of red, yellow, green and black car. Similarly we have sample 2 which we have picked up from the same population. This time during the random selection we have been able to pick up 2 red cars and 2 black cars. It is not a very representative sample. We have sample 3 wherein all the cars which have been picked up from the population is red cars. So now this sample is not a right sample. This sample is also not a right sample. And the reason is because it does not represent all the characteristics of population. Now if you study only red and black car, we would not be able to identify what's happening with green or yellow cars. So that is the reason. Similarly, we have sample 4. So sample is actually a portion of the population. Now let's understand what is a census. The data gathered by the researcher from the whole population is called census. In India, we all know that Aadhaar card is mandatory for everyone. Now during this process of creation of Aadhaar card, the government is capturing everybody's fingerprints and also the basic details. The process of collecting this information from the whole population can be classified as census. So now the question is it viable to do census every time? And I think the answer is no. Why? Because it is not something which is very cost effective in nature and there are a lot of resources which is required in order to do census and it is very time consuming. Now let's understand what are the two main areas of statistics. So two main areas of statistics is descriptive statistics and inferential statistics. Let's understand one by one what is descriptive and what is inferential statistics. Descriptive statistics results from gathering data from a group, body or a population and reaching conclusion only about that group. We'll understand that. What do you mean by when we say reaching conclusion only about the group for which you're collecting the data? We'll understand this in our next slide. Inferential statistics results from gathering sample data from a group, body or population and reaching conclusion about the larger group from which the sample was drawn. Okay, so now we move on and we'll understand descriptive statistics and inferential statistics with the help of an example. For now, what we have to remember is that inferential statistics is also known as inductive statistics. Now let's see this example. In this example, we have two scenarios. Now we have scenario number one. Now when we say scenario number one, I'm just focusing on this portion. Okay. Now in scenario number one, we have gathered data for 4 cars and then we're trying to reach out for conclusion about only these 4 cars. Now in this case, what do you think? What is scenario number one and what is scenario number two? In scenario number two, we've gathered data for only 4 cars, but we're trying to conclude about larger group. So can I ask you which scenario can be classified as descriptive statistics? You're absolutely right when you say scenario number one. Why? Because we are reaching conclusion about the group for which we have collected data. In scenario number two, we are trying to reach conclusion about the larger group. But for this larger group, we have not collected data. We have only collected a sample data to come to a conclusion about this larger group. So this scenario number two is your inferential statistics, and this becomes your descriptive statistics. So let's move on and let's understand what is the parameter and statistics. A descriptive measure of the population is called a parameter, and we can take few examples: population mean, population variance, population standard deviation. All of these are actually parameters, and these are the descriptive measure of population. A descriptive measure of sample is called a statistic, and the examples are sample mean, sample variance and sample standard deviation. So these all are your statistic. Now the symbol P and the symbol S is actually in order to make you remember these concepts. So when we say parameter, it starts with P, and we are talking about population, which also starts from P. So in order to remember, parameter actually represents populations. In this case, if you see, it is about sample, and we call whatever we collect as a statistic. So population mean, now you see U, population is also known as universe. Population is also known as universe. So population mean is represented by mu, whereas sample mean is represented by X bar. Similarly, we have population variances, which is denoted by sigma square, and standard deviation, which is the square root of population variance, which is sigma. We'll understand all of that in detail when we go to measure central tendency and measure of variability. Now let's see, why do we monitor calls? Now let's say when we say this, why do we monitor calls, we are talking about a BPO environment where there are a lot of agents taking calls, and then there is a set of team members, maybe 5 to 10 people, who are picking up random samples and monitoring their calls. So why is that important? The answer to that could be in order to evaluate whether we have been compliant to our processes or procedures which is defined by the client. We do monitoring. It's also a health check of a process, and it also kind of give you the idea of the quality which is being delivered and offered to the customer. Now process quality score of 85% coming out of sample audit, is it a parameter or a statistic? Now process quality score of 85% coming out of a sample audit. Now because it is a sample audit, then it will be a statistic. Now let's move on and understand variable and data sets. Set of measurements observed for a variable is called data set. So we have variables and we have data sets. Now in this example, weight in kg. This particular thing is known as variable, and the numerical values captured under this is known as data set. Similarly, we have other things like height, we have NPS scores, we have AHT, we have car color. All of this is your variables, and the data values captured under them are classified as data sets. Now the question is, classify the variable into quantitative and qualitative, and also identify the measurement scales. Now it is too early for you to really identify the measurement scale, which you will be able to do in a while, but let's understand what is quantitative and what is qualitative. Now anything which describes quantity is known as quantitative variable, and the variables which describes the quality of a variable is known as a qualitative variable. Now when we say quantity, weight 10, 20, 30, 40, 50, it's actually a quantity which you can measure, so it becomes quantitative. Height is something which you measure, it becomes quantitative. NPS, now NPS is 1, 2, 3, 4, 5. It tells you the satisfaction of the customer. It's actually a qualitative variable, but can also be classified as quantitative variable, depending on how do you want to treat it. Then the best practice is to use it as a qualitative variable. AHT in seconds is also a quantitative variable because it is being measured. Yeah, it is numbers. Car color, now it tells you about the quality of the car, which is that it is red color car, blue color car, or a green color car, so it can be classified as a qualitative variable. So let's move on to now and understand again quantitative and qualitative variable. So quantitative variables captures quantity, and it can be described by a number for which arithmetic operations such as average can be calculated, and which should also make sense. Now qualitative variables records quality, and averaging doesn't make sense here. So let's identify variables and classify them as a quantitative and qualitative variable. Price of a flat, now it's money, yeah, and we kind of can take out average of this particular value, so it becomes your quantitative variable. Similarly, we have count of bedrooms. It is also quantitative. Why? Because there is a count quantity associated to it. It can be 1, 2, 3. Similarly, count of bathrooms is also a quantitative variable. Directions, east, west, north, south facing flats. Now this is the quality of a flat. Now it cannot be counted, okay? So this becomes your qualitative variables. Now let's move on and understand the type of measurement scales. So we have 4 type of measurement scales. The first is nominal, second is ordinal, third is interval, and fourth one is ratio scale. Now in order to understand the scales of measurement, what you have to really remember is that nominal measurement scale is a scale where the values doesn't have any order. So if, let's say, I take an example, red, blue, green. Now these are colors, and they doesn't have any kind of order. I can't say red is better than blue or blue is better than green. It varies from people to people and their preferences. But when we are capturing it, it does not have any kind of order. So any variable which is getting captured and does not follow any order can be measured on a nominal measurement scale. Now similarly, we have ordinal. Now in ordinal, we have an order. So as we all know that customer satisfaction can be captured on a scale of 0 to 5, where 0 means the customer is not at all happy, and 5 means the customer is very happy with your products and offerings. So now we all know that 5 is better than 0. How much is something which we can't calculate, but it is better. So it has an order. So 1 is better than 0, 2 is better than 1, 3 is better than 2, and 4 is better than 3, and 5 is the best. So it has an order, yeah. So similarly, we have NPS scores, Net Promoter Scores, which is being rated between 0 to 10, and it also have an order. So it becomes ordinal. Now this nominal and ordinal measurement scales collectively also classified as categorical. Now interval scale, temperature in degrees Celsius or time. Now if I say 100 degrees Celsius is twice that of 50 degrees Celsius, that will not be a right statement to make. Reason being because it's actually 0 doesn't hold any kind of a value in this. Let me take another example to make you understand. Can I say 10 a.m. is 2 times 5 a.m.? The answer is obviously no, because 10 a.m. is not 2 times of 5 a.m. Rather, the correct statement is 0 to 10 a.m. interval is equal to 2 times 0 to 5 a.m. interval. Yeah. So now the moment I measure this in an interval scale, it makes sense. But if I directly say 10 a.m. is equals to 2 times 5 a.m., it does not make any kind of a sense. So because 0 is human defined and it does not hold any kind of a value. That is the reason these kind of variables can be classified as interval measurement scales. So, now we have ratio scales, weight, height, handling time, all of these kind of things can be classified as ratio scales, and in this case 0 holds a value. 0 means absolute 0. Now which scale of measurement is weakest and which is the strongest, we all can make out. Ratio scale are the most strongest scales of measurement, and from an analysis standpoint, in nominal measurement scales, variables captured under the nominal measurement scales, you can perform analysis but very limited. In ordinal, you can perform all what you can perform on nominal. In addition to that, few more analysis can be done on ordinal data sets. Interval, you can perform furthermore, and ratio, you can perform almost every statistical analysis. Now let's move on to type of statistical techniques, and the statistical techniques again is classified into two categories. One is your parametric statistics and second is your non-parametric statistics. In order to understand this, I would like you to focus on metric and this non-metric. So metric actually stands for something which can be calculated on a meter, yeah, or maybe a scale. So when we say parameter statistics, so anything which is being measured on a scale, you can perform parametric statistics, and anything which cannot be performed on scale, you can perform non-parametric statistics. Now we all know that interval and ratio, they are kind of measured on a scale. So you can perform parametric statistics there. For quantitative data, you can perform parametric statistics for quantitative data. And when we perform parametric statistics, we assume that it is normal distribution. For nominal and ordinal data, you can perform non-parametric statistics. For quantitative, ranked or qualitative data, you can also perform non-parametric statistics. And in this, when you perform non-parametric statistics, there is no assumption about the distribution. So that is also great. But majority of the time, we'll focus more on parametric statistics. While if I say that non-parametric statistics is not important, that would not be a right statement to make here. So both statistics are important, but majority of the time the emphasis is more on parametric statistics. So in our next lecture, we will talk about charts and graphs. Thank you for now.